On page 541, we begin with section 12.1. Chapter 12 is going to be dealing with trigonometry, which deals with a whole bunch of different functions and graphs that relate to triangles. So first, let's draw out the triangle. Alright, I have a triangle, and I'm going to be referencing specific angles and sides. So trig functions, they deal with ratios of sides. This means I'm going to have any two sides, so opposite and hypotenuse, and I'm going to be dividing them and putting them into a fraction and maybe getting a decimal. Alright, so I need to look at theta. Theta is just one way to name, it is a Greek letter, it's one way to name a angle. I could also name it angle A, but I'm going to call it angle theta. So theta. I have 6 trig functions, and those trig functions are sine, which written out long ways is sine, and then I have cosine, tangent, cosecant, secant, and cotangent. There's a reason why I put the functions the way they are. There's a relationship between sine and cosecant. There's a relationship between cosine and secant. And there's a relationship between tangent and cotangent. Alright, and the ratio of the sides means that if I were to ask for the sine of theta, so that means I'm looking at this angle, I have the opposite side over the hypotenuse. So the opposite side is the side across from the angle, and I also have an adjacent side, which that is one of the two sides that make up the angle. That is not the hypotenuse. The hypotenuse is always going to be the side opposite of the right angle. So sine is opposite over hypotenuse, adjacent is, or cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I know these three, I should be able to find out the other three. So this is SOHCAHTOA. This is the abbreviation, the word, the fancy word that I told you guys to memorize, and you should be able to figure out everything else. So if I'm referencing a specific angle, I should be able to find the ratio of the sides and solve for some missing parts and some variables. Now, cosecant has a relationship with sine, and it's called the reciprocal. Alright, they are reciprocals. And secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So that means what I'm doing is I'm basically swapping my numerator and denominator, or really I'm taking 1 over sine, and that gives me cosecant. 1 over cosine gives me secant, and 1 over tangent, that's what a reciprocal does. I take 1 over a value, and that gives me cotangent. So instead of it being opposite over hypotenuse, it's hypotenuse over opposite this time. And then hypotenuse over adjacent, and adjacent over opposite. If I can set these up, I can then solve some examples. Alright, I'm going to move on to the example portion of this video. In my first example, I want to find the 6 trig functions of theta, of angle theta. So first and foremost, I need to label my sides. It would be beneficial for me to label my sides. So opposite is going to be 12, the adjacent is going to be the 5, and the hypotenuse I actually don't know. So my first step is I need to find my hypotenuse. Step 1, find my hypotenuse. How do I do that? So if I have a right triangle, I can use the Pythagorean theorem, which you guys should know this from geometry. This is a squared plus b squared equals c squared. So a and b, those are my two legs, and this is c is my hypotenuse. So I plug my numbers in. So that means 5 squared plus 12 squared equals c squared. That gives me 25 plus 144, or 169 is c squared. And in order to solve for c, I need to take the square root of 169, which gives me 13. So my hypotenuse is 13 units long. Now I can find sine, cosine, and tangent of my angle theta. Sine is the opposite, which is 12, over the hypotenuse, 13. Cosine is the adjacent, 5 over the hypotenuse. So, toa. So I need to do the opposite, 12 over the adjacent, which is 5. Now I can find cosecant, secant, and cotangent of theta. And that's just me taking the reciprocal or flipping my values. So 13 over 12, 12 over 5, and that should be 13. On cosine, that should be 13. And 5 over 12. Alright, there are my 6 trig functions. So really the most difficult part is finding my third side. On to example 2. Example 2 uses one of these special right triangles that I talked about. There are 2 special right triangles, and they are the 45, 45, 45, 90, 45, 45, 90, and the 30, 60, 90, 30, 60, 90 right triangle. Alright, so there are these values for this chart. They do have square roots in them, which if I use these values in this chart, it's going to give me an exact answer, versus when I actually plug it into a calculator and round and then find a decimal and then multiply it and find another decimal and then round. It's better to use the radicals and the square roots than keep rounding my answers, because that's going to be less exact. So in this case, my goal is to solve for x. This is my goal, and I need to use the trig functions in order to do so. So first I have my angle 30, my 30-degree angle that I'm looking at. And I have the side adjacent, and I have the hypotenuse. So what trig function uses the adjacent and hypotenuse? I'm going to flip back. Let's see here. Flip back, adjacent and hypotenuse. That's my cosine right there. So the cosine of my 30-degree angle is equal to x over 8. And in order to solve for 8, I need to in order to solve for x, I need to multiply each side by 8. Those are going to cancel out and become 1. So x is equal to 8 times the cosine of 30. And yes, if I type this into my calculator, I will get 8 times cosine of 30, which is about 6.93. However, if I want an exact answer, just find the cosine of 30, or have it memorized. Cosine of 30, so 8 times cosine of 30 is radical 3 over 2. Alright, well, I can reduce this. So 8 divided by 2, that'd be like 8 over 1 times radical 3 over 2. 8 over 2 is 4. So that's 4 radical 3. This is my exact answer. If I asked you to round, then let's say I said round to the 100th, then that would be my answer. However, this is exact and this is rounded. There's a difference here. Sometimes I'll ask for you to round, and other times if it just says find the value, then that means use this chart. Use this chart and make sure that you have square roots in your answer. On to another example. Alright, in example 3, this is not a special right triangle because that's 63 degrees. It's not 30, it's not 45, and it's not 60, but it's 63. So I need to look at this angle, and figure out which sides I have. I have the adjacent and I have the hypotenuse, and I'm trying to find my hypotenuse. So yet again, I'm going to use I highly suggest writing this at the top of your paper. I have adjacent and hypotenuse. Adjacent and hypotenuse, so I'm going to use cosine. The cosine of 63 degrees is equal to adjacent over hypotenuse, 3 over x. So in this situation, you are going to actually input a value and round at the very end. So I need to solve for x. In order to do so, I'm going to write out a couple different methods. Alright, the first of which I'm going to just multiply each side by x and get x out of the denominator. Alright, so multiply each side by x. I can do that. So I get x times the cosine of 63 degrees equals 3. And then I'm going to divide each side by cosine of 63. So x is equal to 3 over 3 divided by cosine of 63 degrees. Alright, in example 2, a lot of you guys are used to doing it this way. You put cosine over 1, and then you cross multiply and divide. So you get x cosine of 63 degrees equals 3, and this is the same setup. So some of you will see just multiply x onto the other side, and some of you will want to cross multiply and divide. It will get you the same place. So I want to go ahead and type that into my calculator. You are going to hit 3 divided by, I would make sure that you're nice and neat and put cosine parentheses 63 and close your parentheses. Some people like to add an extra set of parentheses to make sure that the bottom stays all together, and that will give you approximately 6.6. And that is my last example for 12.1 trig functions. Please see me before school if you have questions.